So this is continuation to the 3.4 notes. Now, for example B, we have f of x equals negative x to the fourth plus 4x to the third plus 8x squared. Now, the first thing we need to do is the first derivative test. So I'm going to go ahead and I'm going to take the first derivative. So the first derivative here is going to equal a negative 4x cubed plus 12x squared plus 16x. Go ahead and set that equal to 0 to find your critical points. Now, keep in mind, your GCF here is going to be a negative 4 and then also an x. So I'm going to factor out a negative 4x because remember, the leading term has to be a positive when you're going to factor. So right here, when I factor out a negative 4, I'm left with x squared minus 3x minus 4. Now I'm going to go ahead and I'm going to factor this part. So that's going to be a negative 4x, x minus 4, x plus 1. When you do the zero product property, you are going to set that part equal to 0 because there is a variable there. So when I set negative 4x equal to 0, I find x equal to 0. When I set x minus 4 equal to 0, that's going to give me a positive 4. And when I set x plus 1 equal to 0, I'm going to get a negative 1. So these right here are your critical points, or your critical numbers. Critical numbers. You are now going to put your critical numbers on a number line. So right here is my number line. It's going to go negative infinity to positive infinity. I need to have the number 0 there. I need to have a 4 and a negative 1. Now, you're going to go ahead and you're going to plug in numbers in each region and find out if they're positive or negative, because this is going to be the first derivative test. So when I plug in, let me plug in like a negative 2. So if I plug in a negative 2 here, so a negative number times a negative number, that's going to give me a positive. Negative 2 minus 4 is going to be negative 6, so that's negative. Negative 2 plus 1 is going to be a negative. So when you multiply a positive, negative, negative, that's going to give me a positive in this region. Next, I'm going to go and I'm going to plug in like negative a half. Negative a half. Now, negative a half, a negative times a negative, that's going to be a positive number. Negative a half minus 4 is going to make it more negative. Negative a half plus 1 is going to be a positive. So then right here, that's going to give me a negative region. A number between 0 and 4, I'll go ahead and I'll plug in 1. And like I said, I'm putting first derivative because I'm plugging in the first derivative. So if I plug in a 1 here, that's going to be a negative. If I plug in 1 here, 1 minus 4 is going to be a negative. If I plug in 1 here, 1 plus 1 is going to be a positive. So that, when I multiply it out, it's going to give me a positive. And then last part, let me plug in a number bigger than 4, so like 5. So if I plug in 5, that's going to be a negative. 5 minus 4 is going to be a positive. 5 plus 1 is going to be a positive. So that's going to give me a negative region. So when I look at the original graph, what that tells me is positive means the graph is increasing. Negative means the graph is decreasing. Positive means increasing. Negative means decreasing. So I'm going to go and I'm going to write my regions. So my interval, sorry. It's increasing on the interval from negative infinity to negative 1 and from 0 to 4. It is decreasing on the intervals from negative 1 to 0 and union 4 to infinity. If the graph is going up and then down, that is going to be called a maximum. And then here it's going down and then up, so that's going to be called a minimum. And then it's going up and then down, so that's going to be a maximum. Now, because these are actual points on the graph, you need to make sure that you are plugging them back into the original. So I'm going to go ahead and I'm going to do my maximum first. So I have a maximum at -1 and I have a maximum at 4. So when I go ahead and I plug in -1 into here, let's see, f of -1, that's going to mean a -1 raised to the 4th plus 4 times -1 to the 3rd plus 8 times -1 squared. So when I plug that into my calculator just as it is, I'm going to go ahead and I'm going to get the number 3. I'm going to plug in the other maximum, which is 4. So when I plug in 4, that's -4 raised to the 4th plus 4 to the 3rd plus 8 4 squared. And when I plug that into my calculator, that's going to give me 128. So those right there are your maximums. I'm still going to have to plug in my minimum, which is a 0. So when I plug in my 0, that's -0 to the 4th, which is 0, plus 4 times 0 to the 3rd, which is going to be 0, times 8 times 0 squared, which is going to be 0. Now keep in mind, the first two were the maximums, the last one was the minimum. So I have a relative maximum at -13 and 128. And I have a relative minimum at x is 0, y is 0. Now that finishes everything that the first derivative gives me. That finishes everything that the first derivative gives me. I'm now going to go ahead and actually, let me go ahead and start sketching my graph. Because I can start to sketch it right now. I don't know how I'm going to graph 128. I'll just estimate. I'll just put it somewhere really, really high. So right here, let's see. I'm just sketching. I'm going to have to go to 128. So let's see. So 128 is somewhere up here. Now I'm going to have 4. So here's 1, 2, 3, 4. So that's actually a point on the graph. So for 128, that's going to be your relative max. And then I'm going to have 0, 0. Here's 0, 0. That's going to be a relative minimum. And then I'm going to have -1, 3. So here's -1. 3 is somewhere really down here. And that's going to be a relative max again. Now I'm going to draw my increasing and decreasing. So from -infinity to -1, it's increasing. So that means it has to be going up somehow like this. And then from 0 to 4, so here's 0, here's 4. It has to be going up. And then it's going down from -1 to 0, so it's going down. And then it's going down from 4 to infinity. So then it starts going back down like this. So I know the graph is going, it goes up, then down. I'm now going to go ahead and I'm going to take the second derivative. So this is all the first derivative. First derivative tells me increase, decreasing, and tells me maxes and mins. Now to find the second derivative. So the second derivative here is going to bring the 3 down. That's going to be -12x squared. Bring the 2 down, that's 24x. And then the derivative of 16x is 16. Go ahead and set the second derivative equal to 0. The GCF here, I'm going to factor out a -4. And that's going to give me a 3x squared minus 6x minus 4. This part right here is not going to be set equal to 0 because there is no variable there. Because technically, if you wanted to, you could divide both sides by -4, and that's completely gone. So this 4 is not going to play a role in any in my possible inflection points, because second derivative gives me inflection points. Now, if you try to factor this part, you're not going to be able to factor it. So if you cannot factor it, we have to turn to the quadratic formula. Now, in case you forgot the quadratic formula states x is equal to -b plus or minus square root b squared minus 4ac all over 2a. So that is the quadratic formula. And it all goes back to y equals ax squared plus bx plus c. So in this case, remember the 4 is gone. Your a is going to be the number 3, the b is going to be a -6, and the c is going to be a -4. So when I go ahead and I plug that into the quadratic formula, x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So when I use my calculator, a negative makes that a +6. When I type all that in my calculator, I'm going to get an 84. And then 2 times 3 is going to give me the number 6. Now, I need to find out what the numerical values are. So if I type in 6 plus square root of 84 divided by 6, that's going to give me x is approximately, remember, we always round to 2 decimal places, 2.528. When I type in 6 minus square root of 84 and then I divide that by 6, I'm going to get a negative 0.528. Now, these right here are called possible inflection points. So these are possible inflection points. Now, I need to go ahead and I need to do a number line now. So I'm going to do a number line for the second derivative with those 2 points on there. This is negative infinity to positive infinity. This is my second derivative test. I need to include those 2 numbers. So right here is going to be the negative 0.528. And then right here will be the 2.528. And we are plugging it into the second derivative. Right here. I will have to use my calculator here to find out when it's positive and negative. Now, when I do my number line, let me go ahead and let me plug in like a -1. If I plug in a -1 in here, actually right here, -1 squared is going to be positive one. That's going to be a -12. And then right here, -1 times 24 is going to be a -24. And then plus 16, that's actually going to be a negative number. A number between here is 0. That's going to be easy because that's 0, and that's positive 16. And then I'll go and I'll plug in the number 3. So if I plug in 3 here, 3 squares 9. 9 times -24, -12 is going to be a really big number. So then, or let me just try that out. I have -12 times 3 square plus 24 times 3 plus 16. That gives me a negative number. Now, keep in mind, second derivative tells us concavity. So on the original graph, that's going to mean it's concave down because it's negative. That's going to be concave up, and that's going to be concave down. So the graph is concave up on the region from this point to this point. So that's going to be negative 0.528 to 2.528. And then it's concave down from negative infinity to negative 0.528 and 2.528. And then it's concave down from 2.528 to positive infinity. Now, if you have a change in concavity, so like right here, how it's going from negative to positive, that is going to be called an inflection point. And if I'm changing positive to negative, that is also an inflection point. So now you have 2 inflection points. You have to go back and plug these inflection points back into your original problem. So if I plug in my inflection points, if I were to plug in negative 0.528 into the calculator, my y value is going to be 1.562. And when I plug in 2.528 into the calculator, into here, here, and here, I'm going to end up getting a 74.883. Now we're going to go back to our graph with this information, okay? So now on our graph, now I always draw my inflection points with a star, and that just basically tells me where it's changing. So if this is a negative, this is 1 right here. So negative 0.5 is right here in the middle. And then 1.52 is actually going to be like in the middle right here. So you're not going to be able to see it that much. So I'm going to draw a star there. So I know it's changing. And then 2.5. So here's 1, here's 2. So 2.5 is in the middle. And then it's going to go up to 74. So let's say 74 is somewhere like right here. Okay, this right here is going to be the 74.883. Now we know it has to cross those points. So now let's do our concavity. So our up. Our up is going to go from negative 0.5, which is right here, to 2.58. Because you have a minimum there, you're going to see the full shape upwards. Like that. You are going to see the full U because the minimum is there. Now your concave down is from negative infinity to negative 5.28. And because you have a maximum there, you're going to see the full shape going down. And then from 2.58 to negative infinity, positive infinity, because you have a maximum, you're going to see the full shape downward. And make sure you hit that maximum. And that's what the graph is going to look like. All right, last example. We are going to sketch the graph. So now they're going to give you some information, such as, let's say, f of 2 equals f of 4 equals 0. The first derivative is a negative for all x values less than 3, less than 3. I'm going to tell you that the derivative at 3 does not exist. The first derivative has to be a positive, or x is greater than 3. The second derivative is negative, and then x cannot equal 3 here. So we're going to go ahead and we're going to sketch our graph with that information. I'm going to take each line apart and then show what it shows on the graph. So right here, when it says f of 2 equals f of 4 equals 0, keep in mind f of x equals y. So what this line tells me is that the point 20 is on the graph and the point 40 are points on the graph. These are points on the graph. So automatically, I'm going to go ahead and graph those 2 points. So here's x, here's 1, here's 2, here's 3, here's 4. So I know that 2 zeros on the graph and 4 zeros on the graph. Now on this part right here, it's talking about the first derivative. So if I were to do my first derivative test line, so right here it says for x is less than 3. So here's 3. For x is less than 3, it's telling me it's negative. And what that means is that the graph is actually decreasing. So the graph is decreasing from negative infinity to 3. So from negative infinity to 3, I know the graph is going downward somehow. And then right here, look, it says it's increasing for x is greater than 3. So this part is this one right here. And then this part right here says it's increasing because it's positive. That's that part right there. So then the graph somehow starts going up. And now at 3, the first derivative does not exist. So right here, it does not exist. Meaning you have some type of point. You have some type of point. And then right here, what this says is that the graph is all concave down. It's concave down, and x cannot equal 3. So in order for this to go down, what ends up happening is it looks like this. So it's going to go down, and it's going to have a point, and then it's going to go down. So there's the graph sketched out right there. And that concludes the rest of the notes.